We're going back to the moon, only this time, the plan isn't just to visit. We're going there to stay. That's the vision laid out by NASA, the US government, and dozens of international and commercial partners. If they can stick to the roadmap, what's coming is far more ambitious than simply landing astronauts again. Landing, while difficult, is something we've done before. The real challenge starts after touchdown, building a lasting presence. A permanent lunar base. In other words, the first small city on another world. No one knows exactly how it will unfold, but we already have clever, practical ideas for how humans can survive and thrive beyond Earth. First comes the question, where do we build? The moon is vast, and every Apollo landing happened near the middle, in relatively flat and safe spots with easy direct communication back to Earth. But that was the 1960s. This time, the target is much more ambitious, the lunar South Pole. This region is dramatic. Craters, mountains, and even remnants of ancient volcanoes. In some low valleys and crater floors, sunlight has been absent for millions, even billions, of years. Scientists believe these permanently shadowed areas are rich in water ice, delivered long ago by comets and asteroids. That ice could be the key to survival, providing both drinking water and fuel. NASA has already flagged 13 potential landing sites for the Artemis program. They sit on small ridges or mountaintops that get sunlight, surrounded by deep shadow terrain. It's an area brimming with scientific potential, but also danger. To live and work here for weeks or months, astronauts will need infrastructure unlike anything we've ever built before. Imagine recreating the essentials of a city, but in one of the harshest, most resource-starved environments imaginable. So where do we start? Surprisingly, with roads and landing pads and solid surfaces to build upon. The biggest obstacle is lunar dust. The moon's surface is blanketed with a thin but relentless layer of ultrafine particles. Each grain is jagged and abrasive, like microscopic shards of glass. During Apollo, it sliced through suit layers, scratched helmet visors, and even clogged vehicle radiators. Worse still, it clings to everything. With no atmosphere and low gravity, once dust gets stirred up, it can travel far. When Apollo 12 landed, the crew deliberately touched down near Surveyor 3, a robotic probe that had arrived a few years earlier. NASA wanted the astronauts to examine it, but the landing also showed just how destructive dust could be when kicked up by a spacecraft. When the Apollo 12 crew visited Surveyor 3, they found something surprising. Even though their spacecraft had landed about 180 meters away, Surveyor had been sandblasted by lunar dust blasted up by the lander's rocket engines. That's how powerful and troublesome this dust can be. So if we're going to build a permanent base on the moon, with rockets landing and lifting off, rovers cruising around, and astronauts walking back and forth, we'll need to get serious about controlling dust. And that starts with building roads, landing pads, and hard surfaces around camp. In the short term, there's a quick fix. The U.S. military has a spray-on soil stabilizer nicknamed Rhino Snot. It's been used in places like Afghanistan to harden desert sand into solid surfaces, especially for helicopter pads, where it helped stop dust clouds during takeoffs and landings. On the moon, it could work the same way, at least as a temporary measure. The downside? We'd have to ship all that material from Earth, and it would essentially cover the moon in microplastics. Not exactly sustainable. For a long-term solution, the European Space Agency is working on something much smarter, turning the lunar surface itself into pavement. Their PAVER experiment uses simulated moon dust and a high-powered laser to melt the regolith into solid, glassy slabs. It's the same basic principle as making glass, since glass is really just melted sand. The concept actually dates back to 1933, when people dreamed of paving desert roads on Earth by melting sand. That didn't work out here, but on the moon it just might. Instead of hauling a giant laser across space, we could harness the sun with something called a Fresnel lens. This clever piece of flat plastic uses concentric grooves to focus sunlight, like a magnifying glass, but much lighter and more compact. At the moon's south pole, where the sun hangs low and shadows stretch long, lasers might still be needed. Either way, paving will be slow. ESA estimates it could take about 115 days to create a single 100 square meter landing pad, just a few centimeters thick. That's roughly 100 times slower than paving roads with asphalt on Earth. But it's a challenge worth tackling. We'll be driving a lot on the moon. Transportation will rely on pressurized rover vehicles, like the Lunar Cruiser, a futuristic RV being built by Toyota and JAXA, Japan's space agency. It lets astronauts travel without wearing a suit, moving directly from their habitat into the rover, and it can support 2 people on road trips lasting up to 30 days. Powered by hydrogen fuel cells, it's designed to explore far beyond the base camp. But rovers are only half the story. We'll still need a place to live. Building a lunar city won't happen overnight, so NASA has already designed the first home on the moon, the Foundation Surface Habitat. Picture a 3-story structure with a metal frame and an inflatable living space, able to support up to 4 astronauts for about a month. In practice, 2 crew members will usually stay inside, while the others explore in the rover. The base level is a sturdy, 4-meter-wide metal module that houses the airlock, EVA suits, and a science station for analyzing lunar samples. Above it, the inflatable habitat will provide the living quarters, a first step toward turning the moon into a permanent outpost. Astronauts will climb a ladder to reach the second floor of the inflatable module, which expands to about 6.5 meters across. This level is where you'll find hygiene facilities, exercise equipment, and even a small biology lab, where plants, animals, and other organisms will be studied to see how they adapt to life on the moon. 1 floor higher is the heart of the habitat, the crew's main living space. Here there are beds, a medical station, a kitchen, and a workstation for computers and communications. It's also where astronauts will double as test subjects, helping researchers understand what long-term lunar living does to the human body. But the inflatable habitat is just the starting point. Once we move beyond the foundation phase, the focus shifts to permanent structures, something sturdier that can shield us from radiation, wild temperature swings, and even tiny but dangerous meteorite impacts. And for that, we go back to humanity's oldest building material, bricks. Just as we can melt moon dust into glass for roads, scientists believe we can bake it into solid structural blocks. These bricks could be used to encase inflatable or metal habitats, forming a protective shell that insulates the interior and keeps astronauts safe. China is already testing this idea. Their concept, the Moonot vessel, is an egg-shaped structure built by robots using bricks made from lunar soil combined with 3D printing techniques. In 2024, Chinese scientists began creating bricks from 5 different types of simulated moon dust, testing 3 different heating methods. Later that year, they sent the bricks to the Tiangong space station, where they're now being exposed to vacuum, radiation, and extreme temperatures for 3 years to see how they hold up. And then, there are the more futuristic ideas. One U.S. company, Skyports, is exploring a concept that looks like something out of science fiction, blowing giant glass bubbles on the moon. The process is essentially large-scale glass blowing. Moon dust is melted into molten glass, then inflated into huge spherical structures using compressed gas. Because the moon has almost no atmosphere and very low gravity, these spheres could grow to massive sizes without collapsing. Add multiple layers with air gaps between, like multi-pane windows, and you get a structure with both insulation and strength. It might not be the most practical solution, but it's an extraordinary possibility. Of course, none of these habitats, whether inflatable modules, brick domes, or glass bubbles, will work without one thing: power. The obvious answer is the sun, and indeed, most lunar missions so far have relied on solar panels. That works fine for short stays, but there's a catch. A day on the moon lasts far longer than a day on Earth. Instead of 24 hours, the moon gets about 2 weeks of daylight, followed by 2 weeks of complete darkness. Apollo astronauts never had to deal with this because their missions lasted just a few days. But for long-term rovers and bases, that 2-week night is a huge challenge. Solar power stops, batteries drain, and equipment risks freezing solid until the next sunrise. Most lunar rovers that rely on solar power simply never wake up once the sun comes back. And if they do, they're never quite the same. They don't operate the way they did before that long freezing night. Now, let's look again at the map of the 13 potential Artemis landing sites. Notice all those deep, dark shadows? Many of those craters are in permanent darkness, places where sunlight has never touched. And that's exactly where we expect to find the water ice that could sustain a lunar city. But with no sunlight, solar panels won't cut it. So, the answer is simple: go nuclear. Nuclear power in space isn't new. China has already been running a nuclear-powered rover on the far side of the moon. NASA has used nuclear generators on Mars for over a decade, and the Voyager probes, launched back in the 1970s, are still powered by nuclear energy. But here's the catch: those systems are tiny. They rely on the heat from decaying radioactive material to produce just a few watts of electricity. Perfect for robots, useless for a city. What we need is a real power plant on the moon. That's exactly what NASA's Fission Surface Power Project is working on. Instead of relying on natural decay, these reactors use controlled nuclear fission, the same process that powers reactors on Earth. Atoms of uranium are split, releasing enormous amounts of heat. And while Earth reactors use that heat to boil water and drive turbines, in space we rely on something called a Brayton converter, which can turn heat directly into electricity. Don't worry about the technical details, it just works. One big advantage of the moon's shadowy craters is that they're naturally cool. Place a reactor down there, and overheating becomes far less of a problem. Of course, there are limits. NASA wants these reactors to weigh no more than 6 metric tons and be no bigger than a car. For a nuclear plant, that's tiny. For a spacecraft, that's still pretty heavy. But it's doable. Interestingly, one of the leaders in this field isn't who you'd expect. Rolls-Royce. Yes, the company famous for luxury cars, has actually been building nuclear reactors for British submarines for over 60 years. Now, they're adapting the expertise to design compact space reactors. Their current microreactor concept could generate between 50 and 100 kilowatts of electricity. On the high end, that's enough to power a small factory or several houses. More than enough to kickstart a moon base. And by combining a handful of these units, we could eventually power an entire lunar city. And there it is, humanity's first real outpost beyond Earth. A foothold on the moon. If we can learn not just to survive there, but to build, grow, and thrive, we open the door to a future where space is no longer out of reach. The moon becomes our gateway to the solar system, a launch pad for exploring worlds we've only dreamed of. This is how we boldly go where no one has gone before.